The fifth question is the half-life of a radioactive substance is 20 minutes. In how much time the activity of the substance drops to 1/16th of its initial value? Options have been given as 20, 40, 60 and 80 minutes. The mathematical model for this situation is R equals lambda n. R is the decay rate and n is the current amount, maybe in number of atoms, or you can measure that in grams, kg, whatever, but it is amount of substance, that is the radioactive substance remaining. Okay, it is current amount and the decay constant. So it shows that R is directly proportional to n. R is also called activity. In the question, the word activity is there here, that is the activity. So R refers to activity. So we should know that activity is proportional to the amount of substance, right? So we can understand this by analyzing this statement, that is half-life of the radioactive substance is 20 minutes. What does it mean? Half-life means if there is an amount of substance n naught that reduces to half in 20 minutes. So this is the meaning. Now if we see here, the activity is directly proportional to n, the current amount that is present, right? So activity is proportional to n, so therefore we can measure this activity in terms of n. A simple common sense, a simple rational thinking will tell us how many number of times it's going to reduce, because it's given that it is 1/16th of its initial value. What is that initial value? The initial value is the activity. They're talking about the activity, initial activity. Now it is 1/16th of the initial activity. So since activity is proportional to n, so we can consider that activity in terms of n also. So n naught reduces to half in 20 minutes. Another, this n naught by 2, because half of that is remaining now. So that reduces to n naught by 4 in another 20 minutes. Similarly, another 20 minutes, n naught by 8. Another 20 minutes, it becomes 1/16th of the original. This is 1/16th. So it amounts to the same thing, that the activity has come to 1/16th. So how much time it has taken? 20 plus 20 plus 20 plus 20, which is 80. So by simple arithmetic, we could understand that it takes 80 minutes. But mathematically, we can solve it this way. How many half-lives have gone? So 1 by 2 power n. That gives me, if there are n number of half-lives that has gone, then there is going to be 1/16th of n naught which remains, divided by the original one. So if we evaluate this, n naught and n naught gets cancelled. So what we get for n, we will get the value as 4. So 4 half-lives have gone. So we can multiply 4 with 20 and we get 80. So the option is D.